I've heard 1 RPM. I mean, 1 RPM, anything less than one full rotation of the shaft isn't going to give us sufficient data. Rob, would you say even 3, 4, 5 rotations would be better?
Yeah, absolutely. I mean, when we're looking for some kind of defect, we're looking for repetition. So to ensure that, you're able to see that repeating signal, you're going to want 3 to 5 revolutions of the shaft to ensure that, it is occurring every time the shaft rotates. But the other thing to bear in mind as well is that when you have something that is very slow speed, there's not a lot of energy being generated. So from a
Mm.
vibrational standpoint, there's really not a lot of vibration to see. So people will then rely on, some kind of high frequency enveloping, some kind of spike energy reading that if it isn't set up exactly as it needs to be, it's very easy to miss those very, very small impacts. And quite often those impacts can be lost, you know, down in the noise floor just because it's low energy. So I think expertise and experience play a part as well. If you don't know exactly what you're doing and what you need to look for and how to set up the vibration data collector properly to be able to identify that problem, very easy to miss it. Ultrasound doesn't have that complexity. So, we're just listening for the presence of some kind of ultrasonic noise. And doesn't matter how fast it's turning, you're still going to get that tick of metal to metal contact if you have some kind of bearing defect, for example. So, it really does encapsulate everything we've already been talking about when we talk about competency curves, and simplicity is the ability to deploy a technology that is going to just improve your ability and make things easier for you to, see the problems you're looking for.
Robert, you have a lot of experience supporting vibration data collectors from various manufacturers. If I've got a 1 RPM or even a 2 RPM bearing, and I want to get 5 to 10 rotations of that shaft or a rotation of that bearing, so I have a good data set. Where do I need to set my acquisition time for my signal on, if I'm using one of SDT's data collectors like the 340, for example, versus a vibration data collector? And do most vibration data collectors have the ability to take a long enough sample?
That's a complicated question and somewhat of a complicated answer.
You're welcome.
Yeah, thanks very much. So, it comes down to focus on the low end of the spectrum. So we're looking for an event that's going to be happening at a low frequency. So in order to zoom in on that low frequency where we're looking for those impacts, we are going to need to set what we call our frequency max. So the maximum frequency of interest low enough with enough lines of resolution or enough resolution in the acquisition, the signal acquisition, to be able to split the individual frequencies apart. And this is getting like kind of a little bit technical at this point, but the ability to generate that kind of collection with the kind of resolution we need, you're going to be standing there for quite a while to collect the data you need to be able to pick it up if you can at all. So, you're going to need to probably spend some reasonable cash on a pretty sophisticated piece of equipment to be able to do that. And it's going to take you an excessive amount of time. So ultrasound, literally, we spend a lot of time in the time waveform, and it's a lot easier to set up and say, hey, just give me a 60-second time waveform or a 40-second time waveform, and let me see what we can hear, being generated ultrasonically from an impacting standpoint. So it can be a lot easier to do.